Hello, welcome to Ekidel, where we train future civil and structural engineers. My name is Fasha Uchet. Today, looking at this structure, it's clear that this is a flat slab, isn't it? Alright, and we know that flat slab, they don't have beams. Am I correct? They only have columns. So what we'll be looking at today is how do you model your flat slab correctly, and secondly, I'm going to be saying some things about how do you now load it. You know that when it comes to those that has to do with beams, we load our beams, isn't it? We put our walls on the beams. Now when it comes to flat slab, what and how do you go about loading your flat slab? Okay, all of this we are going to be explaining in this particular video, how to model, and at the same time how to the proper way of modeling it, and also how to load it. Is that okay? So that's what we are going to be doing in this particular video, irrespective of number of stories, and there are some things I'll be explaining when it comes to flat slab, which is very important, so that when architect is sending you any drawing that has to do with flat slab, from your own mind, you know what you are expected to see. And if you don't see it, you need to contact your architect that when it comes to flat slab, this and this and these are the principles and rule of flat slab, because they might not know. Some of them might not know, some of them are aware out of experience, and some might not know. So you need to let them know, because if you don't know, whatever they give you in terms of flat slab, you just accept it, and then what we come up with will not be actually realistic. So on that note, I'm going to be explaining some things. Is that okay? Alright, so let's dive into the action and see how this can be modeled. Alright, so welcome back, and definitely you must have done your GA from AutoCAD. Is that okay? And once you have done your GA, definitely what you'll be exporting mainly is what is your column. Now when it comes to flat slab, you know that definitely there's no beam. What is carrying your structure, the entire structure, is your column. So on that is why here all we are seeing is what is just your column. Now when it comes to flat slab, how do you now start your modeling of slab, and how do you do your calculation? Is that okay? How do you do your calculation? So if you look at this now, based on what I have done here, can you see this place now? This one is 7. Okay, all of this place, can you see it? Can you see the length? Can you see from this point to this point here is what is a 7,300, and from this point to this point 7,300. That's what we are having here. Now I want to teach you how to calculate your thickness of your flat slab. So now looking at this one now, also can you see this is 6,000? Is that okay? That's 7,300 by 6,000. So if you now look at the area now, let's look at our calculator, and we're having a 6,000. That's 6 times 7.3. What do we have? That's 43. Is that okay? That's 43.8, approximately 44 square meter, which is still okay. It's within the range. Is that okay? So now 44 square meter. Am I correct? Yes, 44 square meter approximately. So now how do you now calculate your thickness of this particular slab based on the principle? Is that okay? Based on principle of a flat slab, in terms of a slab thickness, you can now see that we have a 7,300, and here is what is a 6,000. Now if you look all through, since this is length and width, from the length, the highest dimension rather, from one column to another is what is a 7,300. And if you also look at this place now, is 6,000. Another one, okay, 6,000 based on this 6,000. Okay, based on the architectural drawing is 6,000. This is how it goes. This one is a 1,007 something. All right, so based on that, now how do you now know the thickness? I'll bring up my calculator. Now from this my calculator I will say what is the highest length dimension here is 7,300. So even though we have 7,300 and we now have a 7,500, we must take the highest dimension. Is that okay? So now 7,300 is okay, divided by effective span depth ratio, and this effective span depth ratio is what is 26. So I will now say divide by what? By 26. Can you see now? This is 280. That's 281. Now, which means that, and don't forget that this effective span depth ratio, this value is what is the minimum. This is the minimum. So on that note now, we know that when it comes to flat slab, based on code, the flat slab, no matter the size, even though your area is just 2 square meters, and then maybe when you now do divide it by the effective span depth ratio, is what is giving you let's say what do you call it, 150. You cannot go ahead and use 150, because based on code, the principle says that what the minimum slab thickness, when it comes to flat slab, the minimum thickness of slab is what is 250. The minimum slab thickness when it comes to flat slab is 250. So you cannot go below 250 when it comes to flat slab. Even though when you divide by your effective span depth ratio, you are getting like a 200, 210 or 1 something, you must go ahead and use that of 250, which even make your structure, your slab to be safe, isn't it? Much more safer, isn't it? So now, but in this case now, you now discover that what we are even getting is more than the 250, which is minimum recommended by what? By the code. So on that note now, since this one is already 280 approximately, my flat slab thickness for this structure is no any other thickness than what? Than 300. So what I will be using now for this my flat slab is what? Is 300. Is that okay? All right, so this is how to calculate your flat slab thickness. Now that I've calculated my flat slab thickness, how do I now start modeling, knowing fully well that what is a column? And one thing you should know when it comes to flat slab is that your modeling, make sure both in terms of modeling, both in terms of drawing your column shape and middle shape, make sure that they are not overlapping. You must be able to look at it very well and say, okay, if I go like this way, hope if by the time I want to insert another one, hope it not be overlapping. Is that okay? All right, that's fine. So I'll now come to my modeling. From this model, I'll pick my slab, and once I pick my slab, let's wait for it to come up. Let's wait for it. So once it has come up like this, so definitely we say our slab thickness is what? Is a 300. Is that okay? 300, and then cover, okay, still okay. All right, so above the soil to 25 is okay. Then come to this place now. My dead load, additional dead load, since this structure is for what do you call it, is for office, they are offices. So therefore I'll now come here now. I'll come here and put my what do you call it, 1.7. I'm using 1.7 in the sense that my tie load or terrazzo load is 1.2 and then my partition load is 0.5. Is that okay? That's how it came about. Or what do you call it, dead load. Is that okay? So that is fine. Now coming to this one, since we say it's an office, I'll come here. I'll look for office for above the ground. Can you see now? Office area above what? Ground, above ground. So this is not office at or below ground. No, this one is what? Above the ground. So I'm using 2.5. So now that I've done this one now, so I will not be using, come back to general, I will not be using beam region, because here there is no beam. You see it now, there's no beam. So, and here you might be tempted to be using what? Axis. Yes, good and fine, but if you look at it, can you see it's not giving me what I want? So when it comes to this situation, the best thing here to use is pick point. Don't always use axis. Pick axis, no, or beam region, because here there's no beam. Don't use axis region, just use what do you call, let me say axis region. Let's see, can you see? Yet it's not giving me that one. So what I would use is what is a pick point, which will give me what I actually needed. So I'll come here now. Since, and another thing you need to do, if you look at it now, I have put for this outer column, I've put edge. Let me escape. I've put what? Axis at the edge of this, because this is the outer part. And if you also look at this one again, okay, let's see, I'm coming, okay, there's supposed to be an axis here. We're supposed to put axis here too also. So I'll copy this one now. I'm coming, I'll copy this property, and now I'll bring it here, because I'm supposed to have one at the edge here. Escape, click on this, offset, offset, I'll come here and put at the edge, because this is the outer part of it, isn't it? So I'll come here and put, is that okay? Why is it not giving me? Let me pick from here. Where's my axis? Okay, sorry, I hid my axis. I hid the axis. Display, come to here, axis. Okay, all right, they are here now. So everything is here now. They are all here. So if you notice here, you notice that I put axis here, isn't it? at the edge, at the perimeter. Can you see it now? At the perimeter, this one is the perimeter. Based on this one, this is the outer part. And if you also come to this side now, this is the outer part. If you also come here now, this is the outer part. And if you also come to the end, this is the outer part. Can you see it now? So all the perimeter columns at the edges, you must put what? You must put the axis there. Is that okay? Very, very important, as you can see it now. Can you see it now? All right, so that's fine. So on this note now, let's now proceed to what we are doing. Let me bring up my slab again. Come to my modeling and come to my slab, and then from there, this is 300, and then come here again and use my what? My 1.7, and here right click and pick my 2.5 above ground level, and what is again here? Okay, that is fine. All right, so I'll come here now, pick point. I've explained that aspect. So I'll come here now, this is the perimeter, isn't it? I'll come here now, I'm going to be at the edge, this edge, pick this edge, and also at the center top edge here, and also come down here and pick here, and finally I pick at this edge here. Correct. Let's wait for it to come up. Can you see it now? Can you see what we have done in this place? So don't forget, it must not what? Overlap. Is that okay? It must not overlap. So that is that. I also come here now. Here there's a curve here, isn't it? I'll leave this one for now. So I'll come here again. This is the outer part of this. I'll come here. Sorry, I need to cancel this one here. Come here, click on this one. Now don't forget, it must not, I cannot come here and do it. No, it has to be somewhere here. Is that okay? Come here now and go down straight. Here also, if it's not aligning, to not work. Can you see it now? Perfect. So for in this case now, for me to move on this other aspect now, so you can see this place now. Can you see it? So I'll not use this one because there must not overlap and there must not be space. Can you see it now? I'll come here now, come here, so you can see, come to this one, then come here again, and then finally come here and click. Okay, I've not cancelled this one. It's okay. You must always cancel the previous what do you call it, axis. Is that okay for you to come up? So come here, click on this. So can you see what I'm doing now? So also I'll come here now, cancel this. Then let me continue with this one. Come here, click on this. Now this time around I can now decide to use this one now. Can you see? Come here and make use of this, and then come here and use this. Can you see it now? So the most important thing is that they are not overlapping. Is that okay? And once you come to flat slab, whether there's a column there or no column, no problem. As long as there's a point of intersection. Is that okay? And they are not overlapping. That's the most important thing. Is that okay? So that is that. Okay, so the next thing now, okay, let me work on this also from this point, then to this point, and to this point, and to this point. Okay, I've not cancelled. So let's come here, put here, give it to it here, and do this one here, and come here. Okay, what's happening there? What's happening there? Let me cancel again. Let me do another one. That's not an issue. Come here and finally here. Okay, that one is done. So I'll come here, cancel this. Let me see this one again. Come here, not aligning. Come here, and come here. Okay, that's fine. So come here again, cancel this one. Come here and come here again, and also come here and come here. All right, that's fine. So I'll come here again. Let me continue from this one. Okay, let me complete this one. So click on this, click on this, click on this, click on this. Okay, let me complete all of this. Come here again, then click on that's cancel, then edge, and this place, and this one now will be at the edge. Can you see it now? And this one also at the edge here. Perfect. Is that okay? So this is how you go about it. Is that okay? So come here again, come here from this to this point, and also to this point, and finally to this point. Can you see it now? So I'll pause this video, so when it's come to this place of curve, then we can now come together and then complete it. How to go about this curve area. Is that okay? All right, let me pause this video. So now we can now see where we stop now. And one thing about a flat slab, as I said, that I'm going to be explaining, is that your flat slab must be typical in the sense that whatever column that is starting from the ground must be the same column that is going up. So once you must try your best to ensure that yes, the structure is typical. That means the column you are using from the beginning is one that is going to the last floor. because you cannot start changing your column position knowing fully well that slab are not meant to carry column. What is meant to carry column is beam, and since in this case there is no beam, automatically your column from the ground floor from start to finish. So your column from the ground floor must also be what is going to end to the end of what of the structure. Are we together now? So that is that you must take note of that, so that if the architect model anyhow, you should be able to, and if you have checked it, you discover that there's a challenge. What do? You make sure you call the architect's attention to it, so that's why architect is your friend. I always say that architect, you and architect, you are friends. Is that okay? Either you are knowing him for the first time or not, automatically you are friends. Is that okay? So you should be able to relate, isn't it? So that is that. Now looking at this one now, I haven't done this one now like this. Then how do you now model this place like this? How do you model this curve? How do you now model this curve? Now it depends. It depends. I repeat, it depends on how the architect model it. That's why we have to think of how to achieve it. Is that okay? So for now, I'm going to be using this arc. Let's see this arc. Is that okay? Since we have arc here, I'm going to pick this one now. Okay, I've not let me see. Okay, it's like this. Okay, yeah, it's like this. So I'll click on this one now, this edge here, and also this edge here. Let me see if it will work. Let's now see if it will work at that. All right, so you can now see how this place is being done. Why I just took my time to do it, because this place is somehow challenging. Is that okay? And what I use is this arc. Can you see? I use this arc to get this one. Is that okay? I'm telling you what I use now. So I use this arc to get this one, and then I now use this polyline to now have a connection. Can you see? If I touch it now, can you see the shape? Is that okay? Can you see how I got this one? First of all, is that okay? This curve, I use this polyline, and then for the I use arc to get this particular curve that you are seeing. Then I now come here and use what polyline to achieve this. So you can see the shape, how it comes like this, and like this. Is that okay? If I come to this one, I can also see the same thing. Understand this curve like this and this one, and then from this one also, if I look at it, can you see now? All connected. Is that okay? So that was why it was easy to insert. Is that okay? So it's more challenging, so you have to take your time. If I say I want to do it for us to be seeing, in fact, it will take us a time. Is that okay? To achieve it. Is that okay? Because at times it happens like that. Is that okay? All right, so that's how to get this particular curve. If you now see, let's check our 3D. Let's now see our 3D. Can you see what we have now? You can now see what we have as our curve. Can you see it? What we have as our curve. But don't forget, we have not put our our lift. Is that okay? So let's now go and put our lift. Is that okay? Our lift is somewhere here. So somewhere here, let me click on this. So delete this one. So our lift is somewhere here, around here. Can you see it? Around this place. So since it's a lift, so I don't need this column here. It's okay, I don't need this column here. So let's remove that column. I'll take my lift. I'll come here now. Is that okay? I'll come here. I'll come here. All right. So is what do they call it? A 3. I'm coming. We are using a 230. So since we are using 230, so this place will be 230, and then this one will now be 115, and this one also will be 115. Is that okay? So I'll take it from here, from this point here to this point here. Let's see. Okay, then from this point here to where we are having it here. Is it here? No, it's here. And also from this point here to this point here. Yes. Okay, then from this point here to this point here. That's fine. All right, so that is that. So I will escape, and since I've escaped now, I'll need to put my slab around this place, isn't it? So I'll come here now, take the properties of this, take the properties of this one. I'll cancel this one. It's still on pick point. Every information are still okay. So I'll now see this is the center, isn't it? I'll come here now, pick this point. Also come here, pick this point. Come here, pick this point, and also pick this point. Correct. Can you see it now? So cancel this, then come here now, click on this point and also this point, and come here, this point. As I said, it must not overlap. Is that okay? And pick this point. Let's wait and see. Can you see it now? So this is what we have. So if I now escape now, let me escape and let's check our 3D. you can see how we are modeling it. Is that okay? Can you see what we have achieved now? So you can now see our flat slab based on this, how we have modeled it. Can you see it? So you can see it, how everything have gone up to this level. So you can see. So now, based on what I have said, if the number of floor is G plus 3, for example, G plus 3, that's 4, isn't it? That's G plus additional 3 of floors, that's making a 4. Is that okay? So now, if it's a 4, if it's 5, if it's 6, all you need to do is just to go to your building setup and come to this place and click on what? Insert story. But before I insert story, I want to tell us about your wall. Is that okay? Or let me use okay, let me start about your wall. Now, I was telling you that time that we are going to be talking about the loading, isn't it? Now, for the loading, you are going to be using line load. You are going to be using line load. That's what you are going to use. Is that okay? Because the major part where there are going to be wall, for example, there's going to be wall around this edge all through. If there are going to be walls around this edge all through, understand? Or apart from that, we also have some place where there are going to be what? Major walls. Is that okay? You have to use your line load to get that. Now, how do you now calculate it? How do you now calculate your line load? That's the next question. Is that okay? So now let's now go by this. Let me start from this one. Let me use this one as an example because of to not to do the length of this video. Is that okay? I'll just show you how to go about it. Now, bring my calculator. Now, I haven't brought out my calculator now. Let's now see. Looking at this, what is the height of each floor? Let's see, this height of each floor is 3,500. Is that okay? 3,500. That's the height of this floor. Now, from one floor to another. Don't forget, we already have a slab. A slab of what? 300. So it's going to be minus what? Minus 300. That's the slab thickness, isn't it? So I'll click on this. So I have a 3,200, isn't it? So 3,200 become the height of my block, isn't it? Plus that of the slab, give us a total of what? Of give us a total of what do we call it? A total of 2003. Yes, 2002 rather. The total height, that's our block is 2,300. That's 2,500 minus 300 slab, give us a total of what? 3,200. So now multiply by unit weight of block. Is that okay? Unit weight of block. Is that okay? So that is going to be multiplied by, that's my this answer multiplied by what? Let me go back. 3.2 multiplied by 3.47 give us what? Can you see? No. 3.2 multiplied by 3.47 give us what? Can you see? 11.104 kilonewton per meter. Can you see now? Kilonewton per meter. 11.104 kilonewton per meter. So I'll now come here now, use my line load, come to your loading and come to point, line and area load. So you can now see, click on this one. So we are talking of dead load. It's going to be what? 11.104. Am I correct? I think that's what we are having. So we can now come here now. That's for this, in this case now. Is that okay? I'll pick from this edge now, pick from this place and just put to this edge or this edge here, because the column is already here, isn't it? So I'll just put it on this side and let's wait for it and let's see. So you can now see what we have now, isn't it? This is how you go about it. So if there's a place where there's going to be wall, for example, there's going to be wall around here, you also take your measurement. You have to, it has to be in line with the architectural drawing where the wall is going to be sitting. That's why professionals have to handle it when it comes to flat slab. Is that okay? You must know what you are doing. Let's assume this from here now. We also have wall around this place. Maybe from here now, from this point. Let's say from this point. Then press my control key up to this. Is that okay? You must have done all your calculation. So you can see. Let's even see from here that this up to this point here. Up to this point here. Let me click and let's wait for it. So can you see it now? And from here also we have a wall. Let's say from this point we have a wall. Can you see? Very easy once you know what you are doing. Any point. So you take your measurement. Is that okay? You must have put your ghost axis. Is that okay? Ghost axis in all those parts. Maybe you now have something like this from this point now. Maybe we now have something like this to reach this point here. To this point here. Can you see it now? So sorry. Okay. So to reach that point, let me see. I put it here. Is that okay? I put it here and let me see. I put it here. It's going to go up. It's going to go up there. Let me escape. I will put it back. Escape. So let's see what we have done so far. Let's see what we have done. That's what we have done. That was an issue. Can you see it now? So you can now see how we have put our wall. Can you see? So our wall is sitting directly on our slab. So you can now see how our wall is sitting. So you make sure that those places where the wall is going to be sitting, you put your line load. Are we together? You use your what? Line load. So that's how to go about this. Is that okay? So now I haven't explained this one now like this because I cannot be putting wall in all the place trying to show you. Is that okay? So how we are going to achieve it is what I've explained now. Is that okay? We are going to use architectural drawing to see those places where you are having what? Where we are having wall, and then use a line load to follow it. Is that okay? All right. Once you have done it for one, then you can now do what? You can now generate the story. Is that okay? That's if they are similar. If not, you did floor by floor. Is that okay? You just generate everything and be doing it floor by floor. But if they are the same thing, you just finish all of them on this one and generate the rest. Is that okay? But if they are different, automatically you do this one. Is that okay? You generate all of them to avoid deleting and all of that. So you generate all of them first, and you now take them story by story and do what? And put the wall low. So on that note, now let's now go to our building set out and come here now, and then come here, come to insert what? Insert story. I'll come here G+3, right? So that will be 4 altogether. So click on this one and then click on OK and click on yes. So let's see what we are going to be having. That's what we are going to be having. All right, correct. Generated. Can you see what we have now? So you can now see what we have achieved. Is that okay? So as I said, if the what is here, the arrangement of the wall here is different from this point here, it's better you generate everything first and now take each level and put your main wall. Is that okay? Wall load. But if they are the same thing, you can just do one, then before you know it, you can just generate it. You can see the one we did all generated all through, isn't it? Then you can now delete the last floor. Is that okay? All right. So having explained that now, so you can now see how we have achieved the modeling of this particular flat slab. Is that okay? So this is how to go about modeling your flat slab. Don't mind you, we have done in our previous video, we have done, how to edit those errors that normally come up with what? With a flat slab analysis. Is that okay? When the possible errors that you will get and how to solve those errors. We have done it in our previous video, so go and watch. Is that okay? All right, but today's class, as I said, is how to model your flat slab. So this is how you go about your flat slab, and I've explained that in flat slab, your structure must be typical. Your column from the ground floor, as you can see this one, from ground like this all through. Is that okay? We have not seen a place where I'm changing my column, isn't it? That's part of the principle of what? Of flat slab. So you must know what you are doing on how to achieve it. And you can see the area here is what? It's about 40 something square meters. Is that okay? Which is also within the principles and rules. Is that okay? All right. So that is unlike the slab within the beam that we are saying what the area of your slab is what? Around 30 square meter or less than 30 square meter. But in this case, you can go beyond that. Is that okay? When it comes to a flat slab. Is that okay? All right. So that is that. So thank you very much. I want to say, in case you have not clicked on like button, I want to say please do so, and if this is your first time, please subscribe to our channel so that as we are releasing video, you'll be notified by what? By the YouTube. And from there, if you click on like button, others will also be able to watch and learn how to model flat slab. Is that okay? So that is that I've explained how I've achieved this curve. Is that okay? Because it's going to take time. Is that okay? But if you can practice based on what I've shown you how to go about it, definitely you will achieve it. Is that okay? All right. It's okay then. Thank you so much. Till I see you next time in our next video, which I'll be going to be telling us how to analyze. I've done about analysis, then how to now get your reinforcement. Is that okay? And punching, because this one is what? It's a flat slab without column drop. As you can see, this is a flat slab without column drop. You cannot see any column, any drop. Is that okay? Flat slab without a column drop. Around the column, there's nothing like a column drop. Is that okay? So that is it. In form of a cap. Is that okay? There's nothing like that in this case. So this is how to go about flat slab without what? Without a column drop. So thank you very much. Let's see you next time in the next video. I want to say till then, bye, one love, and keep us together. Don't forget to like and also subscribe. Bye.